Okay, so nice, yeah, loud enough. Right, solving trig equations using exact values. So, sounds more complicated than it is at the moment. Basically, what I need you to know are values that link with angles, and we're going to start with linking with working out radians and things as a different version of measuring angles. But you'll get there eventually. This is kind of a precursor to that. Alright? But you have to be able to solve trig equations given exact values. Now, do you know what I mean by solving a trig equation, trigonometric equation? Anyone give me an example? No? Yeah? Yeah, so we've got sine, cosine, tangent. So a trig equation would be like a linear equation, a quadratic equation. We would say y equals cos of x. Okay? Now, can you all draw the graph of cos of x? Are you happy with that? No? Sine of x and that kind of thing? Okay. Maybe something we need to look at. If you were to put in... Have you got your graphical calculators?
Yes.
Okay. So we can draw the function of cos of x. Okay, I'm going to put this on hold. Just to draw a little sketch then, cos of x, you need to get very comfortable with this. Okay, so you've got to be able to sketch. So what I do is I put a little dotted line for the maximum value, dotted line for the minimum. Now, did anyone notice what cos of x goes up to and down to? Maximum and minimum is not 1.5, it was... No, the y values. It was 1 and minus 1. Okay? And the graph, I've done it a bit short, but it goes up to 360 degrees. Okay? And it has... symmetry about it, okay? And you need to recognize how to do this. Eventually, it's not the objective for today, but it doesn't hurt to go through it. So it goes down to minimum at 180 degrees and then back up to this. So we've got 90, 180, 270. So that's what cosine. Okay. Okay, so when we solve a function of any kind, we are asking to find what x value gives me a particular y value. That's what solving is. If I want to know a y value when I give you an x value, that's substituting and finding a value. Solving is finding the x. So if I say solve cos of x equals 0.6, I'm saying, well, y is 0.6. What x value gives me that? Now, on our graph, that would be something like, if I put a line across, right, now here's the thing about cyclic functions like sine and cosine. Right? You can see in the domain that I've given you, which is from 0 to 360 degrees, how many solutions are there?
2.
2. This one here, this x value, there is another one here. If I do not limit the domain, you've heard the word domain before, how many solutions will there be for cosine equals something? Infinite. Okay? There'll be an infinite number of solutions. Keep going. We talk about this more another time. This, again, isn't really the main focus of today. But if I want to solve this value, cos of x equals 0.6, I'm looking for x. I'm looking for the angle. So x is an angle between 0 and 360 degrees. I know there are 2 solutions in the domain that we're looking at. you already know how to find the angle. How do you do it?
The cosine goes to the other side, so it's cosine inverse.
Can I ask you one thing? I never, ever, ever like to hear when you're solving equations, put that to that side. It doesn't work, right? You might think it does, but it doesn't work. It makes mistakes. So we don't do the cos goes to the other side and change the sign, because we don't. What you did say after that was correct, which is we find the inverse sign. So if cos of x is 0.6, we find the inverse cos. So we do cos to the minus 1 of 0.6 will tell me what x is, the value. Okay. What is that value? Yeah, reach your calculator, solve it, yeah.
Approximately 53.1.
53.1 degrees, you think?
Yeah.
We agree? Okay, so that's a value.
Yeah.
Right. Any smart Alex amongst you that could work out the second solution? Your calculator will only give you one. It won't give you this next one. Well, we can get it to do it. I'll show you this in the future. But now, using mathematical calculation, can you figure out what the next solution is and with the working?
Would
Go
it
on.
just be 360 minus 53.1?
Good. X2 would be 360 minus 53.1. Can you explain why?
Because it's symmetrical.
Because of the symmetry, yeah. So if we go in 53.1 to that point, if we do the same but backwards, we get that other, oh, I've got a line there already. We get the next solution. And we, if we wanted to know the next solution, we could, sorry, am I boring you, Ella? I'm ever so sorry. I'll try harder. You've got your agenda out, rather than, I'm just sorry.
It's about the math.
Right, so what is the answer then? 306.9 degrees. Now, right, here's the thing. What we're doing today, however, is being able to solve equations like this without having a calculator, because you know you have a non-calculator paper. So you need to solve cos of x equals something, and you have to be able to do it without your calculator. So you might say, how on earth am I going to know that 53.1 degree, which has been rounded, is the answer to cos of x is 0.6? You're not. You're not expected to know that. But there are certain values that you are expected to know and remember.
Isn't this very good, like 45,
Yeah.
90, 60?
So, from the graph, we'll start with the easy ones. There are certain ones that you know already, right? Looking at the graph, the easy ones. So, cos of 0, sorry, that shouldn't have been a theta. Cos of 0 equals what? 1. So we know that one. Cos of something else is also 1.
360.
360. So cos of 0, cos of 360, we know those are 1. You have to remember those, you know that. Okay. Pick any others that you know. Yana was going to tell us. What do you know? Not the 45s, 36 ones, the easy ones from there.
Cos of 180 is minus 1.
Is minus 1. That's another easy one, yeah? Any other easy ones? Yeah?
Cos of 90 is 1? 0, sorry.
Cos of 90 is 0. True. And finally, cos of
180. Oh,
Got
sorry.
that.
Yeah, yeah.
270 equals
0.
0. Okay. So there's some that well, they're obvious. Just drawing a graph, you have to remember those. They're easy to remember. Now, the other ones that you are expected to remember, so I'm wondering whether, well, Jan already obviously remembers this, whether the rest of you do. There are other ones which are cos of 30, cos of 60, cos of 45 degrees. You are expected to either remember them or know how to work them out. Anyone remember doing this already? Know them? You do? Okay. Yeah. Have we done this before?
No.
You haven't done this.
Very roughly.
Very roughly
You
and
never
briefly.
explain it well.
Like just
Okay.
once.
Right. So what I'm going to go through is I'm going to go through how we figure out values for cos of 30, 60 and 45. And actually in the same way you are also going to not just do cos, you are going to know sine of 30, sine of 60, sine of 45. You are also going to know tangent of 30, the tangent of 60 and the tangent of 45. And then obviously the easy ones for sine as well. They're not so easy for tangent, but sine of 0, 360 minus 1 as well. I'm going to ask you to do them on your calculator so you can see the shape. Right? You should be able to do sine quite easily. Okay? And we'll be looking at 30, 60, 45 for those ones. Alright? Before I go on to these then, I want you to sketch the graph, find the values for 0, 3, 60, 189, 270 for the sine curve, please, using your calculators. Alright? So sketch the curve and see whether you can figure it out. If I were you, leave the cosine 1 on it and sketch the sine 1 as well. So, your sine and cosine values, you have there. Way to remember, sine starts at 0, goes up. So 0, 1, 0, minus 1, 0. Cosine starts at 1. That's two things to remember. Okay. Start at 0, go up. Start at 1, go down. Sine and cosine. Right. The next three, we're not going to worry about tan of x of these just yet. We will come back to these at another time. 30, 60 and 45 are other angles though that you have to remember. Alright? Now it's not that 30 is a third of 90. Okay, it doesn't work like that. And 60 isn't double 30. Right? So we've got to figure out a way of knowing these. So the next phase to do 30, 60 and 45, right, we start looking at triangles. Okay. What triangle have I drawn, Ella?
Isosceles. Oh,
Equilateral triangle. How do I know it's an equilateral triangle? Because I have the markings on all three sides. Okay. Right, 3 markings, all 3 sides. Now, common sense dictates that I'm going to use an equilateral triangle to solve for which angles?
$60.
60. Why?
Oh.
Because
They're all 60.
they're all 60. Okay. Got a 60-degree angle there.
Abby's here.
Hello.
Hi, Abby.
Ella's okay. She'll be very grateful. It's not Ella's, it's Abby's.
No, but she has mine. Thank you.
Okay, so we've got 60-degree angle. Okay, now what we're going to do is we're going to cut this triangle down the middle. Okay, and it creates 2 right-angled triangles. Okay, now this angle therefore will be what?
30.
30, and that's where I get my 60 and my 30 from. Okay. Now one other, well, I'm going to give you the easiest case scenario, but we don't have to use easiest, but easiest case scenario is we have a triangle where the length of the side is 2 units. 2 units, and that would make, when I've cut it in half, 1 and 1. Okay. Now, what I will also want to do is work out the height of this triangle. Right, so this value here for this height. How do we do that? Sonika? Pythagoras theorem. So what is it? Well, we've got, let's call that b, I've got 1 squared plus b squared equals 2 squared. Right, therefore b squared equals 4 minus 1. So b is the square root of 3. Okay, so this is actually the square root of 3. And here, ladies and gentlemen, is where we leave it in surd form. We do not want a decimal, because how are you supposed to remember a decimal? You're not. You're supposed to remember the surd, the square root of 3, the radical. Alright? Square root of 3, easy to remember. Easy to work out if you forget it. You just have to remember the triangle. Right? If you can remember the triangle, you can always work this out. Now, here comes the trick. Sine, cosine, tangent. Well, we're going to use what we've done before. We're going to use, right, SOHCAHTOA. Because I know with SOHCAHTOA that sine of an angle is opposite over hypotenuse. So I know that sine of, let's take 60, is equal to opposite over hypotenuse, which in this case would be root 3 over 2. There you go. That's the one thing we wanted to do. So up here, look, we can now fill in our triangle thing of it. Sine of 60 is root 3 over 2. Something to remember. Right. What about for you? You should now be able to do sine of 30, cosine of 30, cosine of 60, tan of 30, tan of 60. Can you all work all those out for me?
Yeah.
Good. Okay, so hopefully you've done those. So I've got some answers on the board. Do you agree?
Yes.
Really? Okay.
I agree.
Right, it's a shame.
No, tan, it's
Yeah, so one of
the other way around.
3.
What, this one?
no, tan.
That's fine,
We
is
need to
it?
put the
Tan.
Your swap.
Yeah,
Just swap.
There's root 3 is
So
60.
tan of 30, right? We've got opposite over adjacent, so tan of 30 should be 1 over root 3, yeah? So tan of 30 should be, yeah, okay, we'll give you that. And therefore this one should be root 3, okay, good. Anything else?
Cos of 30 should be root 3 over 2.
Cos of 30 should be root 3 over 2.
got that. It's
Good.
fine.
Yeah.
Just checking that you're paying attention and not just writing my answers down. Okay, so obviously these values are simple to remember.
Yes.
You have to remember them. Okay. We haven't done 45 yet. Okay. So let's have a look at 45. So 45 doesn't come into this triangle. It's 60, 30. Okay. So what we need is a different triangle. Okay. Now this triangle is 90 degrees and isosceles.
What is this isosceles? Like, how do you define isosceles?
Two sides are the same.
Ah, okay.
And what's important about that is that if two sides are the same, these two angles are the same. Well, those two angles are only 45 if it's a right-angled isosceles triangle. So that's important. So that is 45 degrees. Now we need one final thing, which is the lengths of the triangles. So to make it easier, we've got 1, 1. Okay, 1 and 1. And what is the hypotenuse then?
Root 2.
Root 2. Okay, using Pythagoras' theorem again. So now you should simply, the same way that we did before, be able to find sine, cosine, tangent of 45 degrees. Okay. So what is sine of 45 degrees?
1 over 1.
1 over
1.
1 over root 2.
root 2. Thank you. Okay. Cosine of 45 degrees.
1 over root
Okay, so if we see that, what do we know about the graphs of sine and cosine of x at when x is 45?
Yeah, at the same point.
They're at the same point, they intersect. I heard someone say that, yeah. And then finally, the tangent of 45 degrees is 1. Okay. Simple then, yeah?
Yeah.
Right. So you have to remember those. Now I'm going to ask you just one more thing for you to do. Now I've given you the fact that the first triangle was a 2, 2, 2. This triangle is a 1, 1, root 2. But what, if you can't remember those numbers, is it possible to use any equilateral or right angle isosceles triangle? So I'm going to ask you to take this triangle and this triangle. I want you to change the side lengths. So maybe you pick a 5, 5, 5, or you wouldn't do that because it's got to be split in half. Maybe a 4, 4, 4 triangle or a 6, 6, 6 triangle. I want you to show that the results of what we've done would be the same regardless of the size of the triangle, please. And we'll take a little bit of simplification, which is why we're doing it. Okay? So just draw a sketch yourself, maybe a 6, 6, 6 triangle. Try and also find sine, cosine, tangent of 30 and 60 using a 6, 6, 6 triangle.
Yeah.
Yeah? Okay, next phase then. So we've got to use these pieces of information. Okay, we could do it 2 ways. Right. So let's say we had to solve something like 2 sine x equals root 3. Right. How do we go about solving something like that then? So we have to find the angle. What do you do first? Okay.
We divide both sides by 2.
Yeah, so if we do the whole both sides by 2 thing, we get left with, they cancel, become 1, so we get 1 sine x, so we get sine x equals root 3 over 2. Does that work?
Yeah.
Yes.
Okay, so what would x be in that case? Without a calculator, Ishan?
Sine 6.
Pardon?
I'm sorry.
60.
60.
Oh, yeah. I see.
60 degrees. How do I know that sine x? Because I remember my angles with my links to these things. Okay? Root 3 over 2. Sine of what is root 3 over 2? Have to remember it. Okay? So the 2 parts to that, remembering that, but also if I've got 2 sine x's, I can rearrange. Okay? What about if I have sine of 2x equals, what do I want? Sorry, bear with me. So if I want to solve sine of 2x equals 1 over root 2. Okay, right, so we've got to solve sine of 2x is 1 over root 2. Aaliyah, do you want to talk me through how you went about it?
I don't exactly know because I need to the sine 45 was 1 over root 2.
Okay, right, so fine. Sine of 45 is 1 over root 2. We've remembered that. So we've got one final stage there. If sine of 2x is 1 over root 2 and sine of 45 is 1 over root 2, logically speaking, one other statement can be made, which is
2x equals 45.
2x has to equal 45. which means x must be 22.5 degrees.
I thought I got it wrong.
Okay?
Yeah, you're right.